On your number 7 for the flipped for 6.5, we're going to find all 6 of these based on the formulas. Before you start this video, please have your formulas ready in front of you for your trig book written down. Okay, so there's a lot of yellow boxes in this section. If you notice, for the double angles, there's only one for sine. There's one formula, but for cosine of 2 theta, there's 3. So you get to pick which one is the most appropriate. The first one we're going to do is problem 7. And what is problem 7? Problem 7 is sine of 2 theta, or sine of theta, equals 3/5. And it says our theta is in quadrant 1. Before we continue any further, when we're doing half angles, so for example, if we're trying to find sine of theta over 2, then what I have to do is I have to take my domain here. We know that theta belongs to quadrant 1. But for this one, we have 0 is less than theta is less than pi over 2. This is my theta right here, but we seek theta over 2. So what we're going to do is we're going to divide everything by 2. Now these two match. When you divide this by 2, this is going to equal pi over 4, which still means we're in quadrant 1. We're still in quadrant 1, but when you're doing half angles, it's very important you have to change your domain, and we'll talk about that more in class. Okay, so we're going to do all 3 double angle formulas for sine of theta and all 3 half angles. In your book, you only have to do 4, but in class we're going to do 6, so I'm going to do 6 here. Given that we have this, we know that cosine of theta is 4/5, because you know your triples. And we know that tan of theta is 3/4. I'm going to try to remember that when I go through the slides. Okay, so first one. The first one is we're going to find sine of 2 theta. And we're going to use our formula. And this is a very important formula, by the way. You'll use this in calculus quite a bit. So sine of 2 theta is 2 sine of theta times cosine of theta. So you just plug it in. Sine of theta is 3/5. Cosine of theta is 4/5. You can write this 2 as a fraction if you want. That's 2 over 1. And so we're going to get 24 over 25. And you're done with that one. Okay, cosine of 2 theta. I'm going to go ahead and use cosine squared minus sine squared. So cosine squared of theta minus sine squared of theta. Okay, so cosine of theta is 4/5. And we're going to square that. Remember, technically, the square really goes where? There. So it's really this. Minus sine squared of theta is 3/5 squared. And we're going to subtract 16 over 25 minus 9 over 25, which equals 7 over 25. And you're done with that. Now we're going to do cosine of tan of 2 theta. Tan of 2 theta equals 2 tan theta These are the ones right here, the tangent, the ones I don't really have memorized. 1 minus tan squared of theta. Alright, so tan of theta is 3/4. So let's write that again. Tan of theta is 3/4. So you just plug everything in. You're going to have 2 times 3/4 over 1 minus 3/4 squared. Again, you can erase this square, and this is what basically it really means. Okay, now just clean it up. I'll put this in fraction form. So this is going to be 6/4 over 1 minus 9/16, which gives me 6/4, in different colors, 6/4. And what I do when I see something like this, I've got the same denominator, right away, and I usually do it at this step, I'm going to change this to 16/16, because that equals 1. So that's just going to be 7/16. Now I'm going to come this way and write this as 6/4, and I'm going to flip this and switch the signs, change it to times. 16/7. 4 goes into 16 4 times, so basically I get 24/7, and that's my answer. Okay, now we're going to do the half angles. We're going to do a sine of theta over 2. And remember, we halved our domain, so now we're in between, our theta's in between 0 and pi over 2, or theta over 2 is in between 0 and pi over 4. Again, we'll go over that more in class. So, we're going to use our formula, and for this one, it is square root. Since we're in quadrant 1, we're going to use the plus, because sine is positive in quadrant 1. We're not going to use the negative. So we're going to have 1 minus cosine of theta over 2. So we're going to get plus square root of 1 minus 3/5 over 2. And make sure you put your radical over the whole expression, which is really the square root of 5/5 minus 3/5 all over 2, which equals the square root of 5 minus 3 is 2, so 2/5 over 2. Now, I'm going to do this one time, or I'll do it in class as well, but right here, anytime you see like this, something like this, all you have to do is multiply these two numbers. And why is because, I'll do it over here, 2/5 divided by 2 is the same as 2/5 times 2/1, 1/2. So basically that's going to be 2/10. So all I had to do, instead of doing all of this all the time, just multiply these two and you have the square root of 2/10. Now again, I guess I'm going to work backwards. So this is the square root of 2 over the square root of 10. We have to rationalize the denominator, so we're going to multiply it by root 10 over root 10, which gives us the root 20/10. At this stage, we can reduce this as the square root of, let me erase this here, square root of 4 times 5/10, which is 2√5/10, and I can reduce this as root 5/5, because 2 goes into 10 5 times, and that is basically your answer. Okay, same thing for cosine. Cosine of theta over 2. We're still in quadrant 1. So this is going to be square root, and our square root is going to be a positive. 1 plus cosine of theta over 2, which is a square root of 1 plus 4/5 over 2, which equals the square root. Now at this stage, what I tend to do when I see something like that, right at this stage, to save me writing on paper a lot, I'm going to change that 1 to 5 over 5, because that equals 1. And right away I get 9 over 5, all divided by 2. Make sure your radical covers the whole bit. And then we get square root of 9 over 10. I'm going to go over here and start breaking that down. So this is the square root of 9 over the square root of 10, which equals 3 over root 10. I have to rationalize my denominator. So I get root 10 multiplied by root 10 over root 10, which is 3 root 10 over 10. And that is your final answer. Now, on the last one, we have tan of theta over 2. You have two formulas in your book, right? You have one that's 10C, and you have one that's formula 11. I suggest, and on the next video, I'm going to use both formulas to show you why, but I suggest you never use 10C and always use formula 11. It makes it easier. So the formula I'm going to use is 11. And that's going to be 1 minus cosine of theta over sine of theta. Or you could say sine of theta over 1 plus cosine of theta. Remember this flip-flop thing? These are equivalent. You proved that in section 6.3. Okay, so I'm going to go ahead and just use this one because it comes first and it really doesn't matter. And I know that it's 1 minus cosine of theta is 4/5, and sine of theta is 3/5. I'm going to change this to 5/5 minus 4/5 over 3/5, which is going to be 1/5 divided by 3/5. And I think we've done enough of this to know that you can cross those out. So my answer is 1/3. And that would be it. Your other flip problems I'll do on another video.